how to find Maclaurin or Taylor series for a given function. Let's suppose that the function f is given, and let's try to find a0, a1, a2, all of these real numbers where fx is equal to a0 plus a1x minus c plus a2x minus c power 2, where c any real number. So we will suppose also here that c is also a given real number. So let's begin by calculating what the derivative of f at the number c. It will be a1, because all of the other terms here from a2 will be 2a2x minus c. Here, 3a3x minus c power 2. If I put c, it will be 0. Okay, what is the second derivative of f at c? So let's write in details a little bit. What is f derivative x of? F derivative x, it's a1 plus a2 x minus c plus 3a3 x minus c power 2 plus etc. So if we calculate f second derivative of x, it's 2a2 plus 6a3 x minus c plus etc. So from here, if we calculate f derivative at c, it will be a1. If we calculate here f second derivative at c, it will be 2a2. If we calculate f three derivatives at c, it will be 6a3 or 3 factorial a3. So if we take what is the derivative n times of this term, only this term, it will be n factorial an times 1. Okay? Because if I take the first derivative of this term here, it will give me a1, because I have power 1. And if I take the derivative 2 times of this term, 2 times, it will give me 2a2. So if I take the derivative n times of this term here, I will have n factorial an times 1. So I can write in general here that if I take the derivative of order n at c, the answer will be n factorial times an. So now I can calculate an. If I know the function f, I can calculate each number here, a0, a1, a2, etc. So an equal the derivative of order n of the function f at the number c divided by n factorial. So this is our next theorem here. If we suppose that the function f has derivatives of any order at the number c, so the first, second, third, all the derivatives at c are exist. Okay, so the function f will be given by this formula. Why? Because if I go back to here, so in the end, after finding all of that, let's write in blue in the end that fx equal, what is a0? A0, it's f at the number c. If I calculate f at c, all of these terms, a1 times 0, a2 times 0, it's a1, a0. A0 is fc. Plus, instead of a1, I will take a1 is equal to the first derivative here. So it's a1. Instead of a1, I will write the first derivative. So it's the first derivative at c times x minus c plus the second derivative at c over 2 factorial times x minus c power 2 plus, because a2 equal second derivative of f divided by 2. So what is a3? a3 is third derivative of f at c divided by 3 factorial times, this is a3, times x minus a3 times x minus c power 3 plus etc. without step. So this is my rule here. So this rule says that the function f is written like this. So if you write the f in details, fx will be, if I give n 0, the derivative 0 times of the function f, so there is no derivative, so it's f at the number c, divided by 0 factorial is 1, times x minus c power 0, it's 1, plus, for n1, it will be first derivative at c divided by 1 factorial times x minus c, plus the second derivative at c divided by 2 factorial times x minus c power 2, plus the third derivative at c over 3 factorial, I give n3 in this formula, times x minus c power 3, like this without the stop. So what is the general formula? For n, it will be this term, derivative order n at c over n factorial times x minus c power n plus without stop. So this series is called Taylor series of the function f about c, because here I have the center c. We'll see later how to find the center of the radius of convergence of series like this, how to calculate this in the exercises. Now, if the number c is 0 in particular case, so I will call this series Maclaurin series for the function f. So let's take an exercise. Prove that Maclaurin series of fx equal 1 over 1 minus x is sigma x power n. We know this before because this is geometric series. Now, how to calculate this? Let's write fx as 1 minus x power minus 1. So what is the first derivative of f? It's minus 1 from the power. I have minus 1 times derivative of 1 minus x, also minus 1, times 1 minus x power minus 1 minus 1, it's minus 2. So the final answer, it's 1 over 1 minus x power minus 2. I can write it also 1 minus x power minus 2, because I need this to calculate the second derivative. Second derivative is also minus 2, the power here minus 2, times the derivative of 1 minus x minus 1, times 1 minus x power minus 3. So the final answer is 2 factorial times 1 minus x power minus 3. If I continue like this, I will find that the derivative of order n of the function f is equal to n factorial times 1 minus x power minus n plus 1. So let's use the formula for Maclaurin series. The formula is fx equals sigma, the derivative order n at 0, Maclaurin at 0, over n factorial times x power n from n equals 0 to infinity. So here, what is the derivative of order n at 0? give x 0, so the answer is n factorial. So let's write here sigma n factorial divided by n factorial from 0 to infinity times x power n. So the final answer is x power n from 0 to infinity. This is fx. What is fx? It's 1 over 1 minus x. So it's the same formula of geometric series, which you know before. And you know that this formula is correct only when x between minus 1 and 1. The next exercise, find Taylor series of e power x about 1. So here I will use the formula that fx equal sigma, the derivative of order n at 1 divided by n factorial times x minus 1 power n, where fx, where I suppose fx is e power x. So what is the derivative, the first derivative of f? It's also e. Second derivative, also e power x. So the derivative of order n of my function fx, it's also e power x. So what is the derivative of order n at 1? So it's e power 1, so it's e. So let's write now, my function fx is e power x, could be written as sigma, derivative order it's always e over n factorial times x minus 1 power n. So from n equals 0 to infinity. So this is the final answer. So this is Taylor series about 1 because I have x minus 1. The last exercise, find Maclaurin series of sine x. Maclaurin means about 0. So I must write sine x like sigma an x power n from n equals 0 to infinity. So before this exercise, let's go back to the last exercise. In fact, we can verify that we can find the radius of convergence of this series. At first, let's take, this is Taylor series, about 1. If you want to calculate Maclaurin series, let's calculate Maclaurin series of e power x. Maclaurin series of e power x. How to find this series? The formula the same, but here 0 instead of 1. So it will be e power x will be sigma, the derivative of order n of the function, the derivative of order n at 0 over n factorial times x power n from 0 to infinity, and fx here is e power x. So what is the derivative of order n of fx? X will be also e power x. So at 0, derivative of order n at 0, e power 0, it's 1. So I will have this formula in red, I will write it, it's so important formula. E power x, it's sigma 1 over n factorial x power n from 0 to infinity. So where this formula is correct, we solved this exercise in a previous lesson about this. The lesson was called radius of convergence, and the radius was infinity, and the center is 0. So it's this formula is correct on c minus r, c plus r, c minus r, c plus r, the interval of convergence, c plus r. So what is the interval will be? Minus infinity, 0 minus infinity, 0 plus infinity. So it's r. The interval of convergence is r. So this formula is correct for any real number x. So we can write this formula like this: e power x equal, if I give n 0, 0 factorial is 1, plus x over 1 plus x power 2 over 2 factorial plus x power 3 over 3 factorial plus x power 4 over 4 factorial, etc. This is correct for any real number r, for x and real number. So we can give x0. If I give x0, I will have 1 equal 1. If I give x1, I will have this important formula. If I give x1, I will have the number e, which is nearly 2.7, equal 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial, like this without stop. Let's go back to our last exercise here. How to find an? It was an here was the derivative of order n to my function order n at 0 over n factorial. So the function fx is sine x. What is f derivative x? It's cosine x. What is f second derivative x? It's minus sine x. So what is f third derivative of x? It's minus cosine x. Now the fourth derivative will be sine x. Now here I will come back to my first function. Okay, I need everything at 0. So let's write what is f derivative at 0. It will be cosine 0, 1. F second derivative at 0 will be 0. F third derivative at 0, it will be minus 1. F fourth derivative at 0 will be sine 0, 0, the same as f0. So let's repeat the formula. What was the formula of the how to calculate fx? It was sigma fn at 0 over n factorial x power n from 0 to infinity. And we can write this also as f0 plus f derivative at 0 over 1 factorial times x plus f second derivative at 0 over 2 factorial times x power 2 plus f third derivative at 0 over 3 factorial x power 3 plus without stop like this. So f is sine x equal f0 here, let's write in red the number, only let's write the 0 in red. This is 0. And this term also, second derivative is 0 from here. And the fourth derivative is 0 also from here. So if I take the fourth derivative will be 0. So only the odd derivatives will be not 0. So f derivative 0 will be 1. So here it's 1. So I have 1 times x, so it's x. And here 0, then here x power 3. F3 derivatives will be minus 1. Minus 1 times x power 3 over 3 factorial. Here I have 0. After this 0, it's like the beginning. Then after that, I will repeat positive 1, 0, minus 1. So positive 1. So I have x power 5 over 5 factorial. Then 0 times x power 6. Then minus 1 times x power 7 over 7 factorial plus x power 9 over 9 factorial minus x power 11 over 11 factorial, 11 factorial plus etc. without stop. So this is the Taylor series of the function sine x. And if we want to write this as sigma, so we can write it like this, sigma minus 1 power n divided by down always odd number. So 2n plus 1 factorial times x power 2n plus 1. So if I give n 0, I will have here plus and down 1 over 1 times x power 1, so it's x. If I give n1, I will have minus here, down 3, and x power 3, so minus x power 3 over 3. If I give n2, I will have minus 1 power 2, it's plus 1, over 5, x power 5, so it's plus here. So everything is good. And remember that if we calculate what is sine 0, it's 0, give x 0, everything, so it's correct. Okay. So from this formula, let's write instead of x pi over 2. If x equal pi over 2, so we will have sine pi over 2, which is 1 equal pi over 2 minus pi over 2 power 3 over 3 factorial plus etc. So we can write this as sigma minus 1 power n over 2n plus 1 factorial from 0 to infinity times pi over 2 pi power 2n plus 1 over 2 power n 2n plus 1. So all of this is equal to 1. Okay, like this we can prove some formulas by giving x some numbers. We can verify using ratio test that this series of sine x is correct for any real number. So radius of convergence, we can calculate this. It will be infinity. So this formula is correct for any real number